Imagine having an assistant who is just undeniably brilliant. I mean, world class in basically every possible discipline you can think of.
Right.
Like, you can hand them a dense 500-page financial report, and they can synthesize it into this perfect executive summary in, seconds.
Yeah, or they can write flawless code or draft elegant emails.
Exactly. They can reason through some of the absolute most complex strategic problems you can throw at them. But, and this is a massive, incredibly frustrating catch here, every single morning, their brain completely resets.
Oh, wow.
Yeah. They retain all their raw intelligence and reasoning skills, but every single time they walk into your office, you are just a total stranger to them.
It sounds like a nightmare, honestly.
It is. I mean, they don't remember the project you spent 6 hours brainstorming yesterday. They have literally no idea what your communication preferences are. And they certainly don't remember the long-term goals you set together last week.
Yeah, working with someone like that wouldn't just be, frustrating. It'd be entirely impossible. You'd spend your whole day just catching them up to speed before you could actually get any real work done.
Which makes them entirely unemployable in the real world.
Absolutely.
And yet that is the exact default state of modern AI language models today.
It really is.
That amnesia is what we are dealing with every time we open a new chat window. And it's exactly what we're unpacking in today's deep dive. We have an incredibly fascinating stack of documents to go through with you today. Everything we're looking at was published in May 2026 by Kelsi Guidry.
With some research assistance from Anthropic's Claude, yeah.
Right.
And it's a very comprehensive set of sources. We're looking at a revised technical white paper, and that's titled A Cognitive Architecture for AI Agent Memory.
Along with a companion paper, right?
Yeah, detailing the reference implementation, plus a blog post that announces a live public alpha release of this whole new system.
So the mission for our deep dive today is to explore how researchers are attempting to cure this AI amnesia. And they aren't doing it by just, throwing more computing power at the problem.
No, they definitely are.
They are doing it by literally mapping the human brain's memory architecture directly onto artificial intelligence. And we are going to look at how you can actually test a working version of this architecture right now.
So the white paper, it starts with a very clear diagnosis of the foundational issue. A large language model just inherently has no persistent memory whatsoever.
None.
Right. Its knowledge is entirely frozen the exact moment its training run finishes. So when you sit down to interact with an AI, it only knows what you paste into its context window for that specific isolated conversation.
And the second you close that window,
the slate is wiped entirely clean. Exactly.
No, I know anyone who works in tech is probably screaming at their device right now saying, wait, hold on, we already solved this.
Oh, for sure. They're thinking about RAG.
Right. The industry has been completely obsessed with ARGRI for a while now, retrieval augmented generation.
Yeah.
And the thought process is, if I can just search a massive infinite database of my company's documents and automatically hand the relevant ones to the AI right when it needs them, doesn't that functionally solve the amnesia?
It feels like it should.
Yeah. It's like the AI has a photographic memory of a giant filing cabinet.
And that is the exact analogy the industry has been operating under. But, well, the white paper argues that this is a fatal oversimplification.
A fatal oversimplification.
Yeah. Treating memory purely as a database lookup is just a Band-Aid. It's not a cure. Because the system you're describing, ARGI, it takes a mountain of documents, mathematically embeds them into a vector database, and pulls out whatever text is semantically similar to the user's prompt.
Okay, but why is that bad?
Well, if we look at how actual cognition works, ARGI falls completely short. The white paper actually provides a pretty brutal assessment of it. It literally calls ARGI a filing cabinet attached to a brilliant amnesiac.
Wow. Okay, so having a great filing cabinet doesn't mean the assistant actually remembers anything. They're just really fast at opening drawers.
Precisely. And the mechanical problem with a RAG is that it collapses what should be distinct cognitive steps. I mean, encoding information, consolidating it, storing it, and retrieving it, it collapses all of that into one flat, simultaneous operation.
Which means it's just doing everything at once.
Right. When you just dump search results into an AI's context window, the system has no idea what information is actually critical and what's trivial.
Oh, I see. It doesn't know if a document is outdated either.
Exactly. And perhaps most importantly, a flat RAG pipeline has absolutely no concept of forgetting.
It just hoards everything equally.
Yes, it just piles it up. The author cites a March 2026 survey by Pengfei Du that really hammers this home. The survey explicitly states that long context is not memory.
Long context is not memory. That's a great way to phrase it.
Right. Dew points out this absurd imbalance in the AI industry right now. Like, companies will spend months of careful engineering, benchmarking, and fine-tuning to select the perfect language model.
But then what? The memory gets ignored.
Essentially, yeah.
Yeah.
The memory architecture for that multi-million-dollar model usually gets like an afternoon of engineering work. It's totally an afterthought.
An afternoon of engineering to build the memory for an intelligence we want to run our actual businesses. That's just wild.
It exposes the real open problems we haven't solved yet. I mean, how do we retrieve information based on an underlying cause or association, rather than just surface-level keyword similarity?
Right.
How does an AI reflect on its own data without accidentally entrenching hallucinations or errors? And how does it safely forget things that no longer matter?
And you just cannot answer those questions with a flat database lookup.
You really can't.
Which brings us to the major pivot in Kelsi Guidry's white paper. Because instead of trying to invent a new database structure from scratch, the proposal is to look at the only system in the known universe that actually handles memory elegantly.
The human brain.
The human brain. Specifically, they draw on a framework from cognitive psychology that actually dates back to 1968.
Yeah, the Atkinson-Shiffrin multi-store model of human memory. It's pretty foundational to understanding human cognition.
So how does a 1968 psychology paper help in AI in 2026?
Well, what's brilliant about this white paper is how it takes that biological blueprint and translates it directly into distinct engineering layers for AI.
So we get layers instead of just a bucket.
Exactly. Instead of one flat database, we get a multi-stage process.
Yeah.
5 layers, to be exact.
Let's trace how a piece of information actually moves through this proposed system, because this is where the mechanics get really fascinating for you as the user. It starts with the intake, right? What the paper calls sensory ingestion.
Yep. Think of this as the raw, unfiltered stream of consciousness. Everything the AI agent sees, hears, reads, or fetches lands in this layer first.
Okay, so it just captures everything.
It does, but this layer isn't trying to understand the data. Its only mechanical discipline is enforcing provenance.
Provenance.
Right. It captures the raw signal and strictly tags exactly where it came from at what exact time.
Why is provenance the only rule at that intake stage?
Because if an AI cannot trace a fact back to its exact origin, it cannot answer the fundamental question, where did I learn this?
Ah, I see.
And when AI loses provenance, that's when it starts hallucinating sources to fill in the gaps. By strictly enforcing provenance right at the point of sensory ingestion, you guarantee the system always has a receipt for every piece of knowledge it claims to hold.
That makes total sense. I mean, if you're relying on this agent for legal research or coding, a hallucinated source is just a total deal breaker.
Well, absolutely fatal.
So the information comes in, it gets a receipt attached to it, and then it moves into the active workspace.
Yeah.
The short-term working memory.
Right. And in the context of AI, the working memory is the bounded context window of the language model itself.
So just the current chat session.
Basically, it's whatever the AI is actively holding in its mind to complete the current conversation or task. Just like human short-term memory, it is inherently small, it's temporary, and it's volatile.
Right.
Once the conversation is over, or the task is complete, that workspace clears out completely to make room for the next task.
But wait, if the workspace clears out, how does the AI actually retain the important stuff?
Well, that leads to what the white paper calls the most architecturally important layer.
The consolidation bridge.
Exactly. And it's the one that is almost entirely missing in modern AI.
Yeah. When I was reading how this mechanism works, I immediately thought of human sleep.
Yes.
Like, if humans consolidate their memories during REM sleep, sifting through the chaos of the day, keeping the lessons, and discarding the noise, it sounds like this architecture literally requires the AI to sleep.
That is the exact biological metaphor the author uses. Consolidation cannot happen while you are actively chatting with the AI.
Why not?
Because if the system tried to organize its entire long-term memory while you were waiting for a response, the latency would be unbearable. You'd be waiting forever.
Oh, right. It would be doing too much computing at once.
Right. So consolidation functions as an asynchronous worker. It's a background process that spins up off the critical path, but only after your session is closed.
So it's looking back at the transcript of my chat from that afternoon and deciding what actually matters.
Exactly. It's doing active cognitive work.
Right.
It looks at the temporary working memory and decides relevance.
Give me an example of how it decides what's relevant.
Sure. So, for instance, if you spend 10 minutes complaining about the weather before giving the AI a project requirement, the consolidation worker just discards the weather talk as irrelevant noise.
But it extracts the project requirement.
Exactly. And crucially, it handles a mechanic called supersession.
Supersession. How does that work in practice?
Okay, let's say your AI agent learned on a Monday that a specific client uses a PostgreSQL database. It stores that fact.
Got it.
But then on Friday, you have a meeting, and the agent learns the client just migrated everything to MySQL.
Okay.
Now, a standard flat database would just save both facts. Then next month, when you ask what database the client uses, the AI might pull up the Monday note and give you the wrong answer.
Because both facts are technically true historical records of what was said on those specific days.
Right. But the consolidation worker actively recognizes the contradiction. When it processes Friday's session, it doesn't just blindly add the new fact to a pile.
It supersedes the old one.
Yes. It flags the Monday note as historical and updates the core understanding to MySQL. It encodes the actual meaning of the events rather than just saving a verbatim transcript.
It's actively curating its own understanding of the world.
That's wild. Okay, so once the AI has slept on this new information, curated it, and superseded any outdated facts, where does that information actually live?
That's layer 4, the long-term memory layer.
And here again, the architecture completely avoids the trap of a single massive bucket. Long-term memory is proposed as 3 co-located stores working together.
3 different stores.
Yep. First, you have the canonical store, which holds the highly curated human-readable text.
Okay.
Second, there's a retrieval index, and this is where your vector databases come in, allowing for incredibly fast similarity searches across all that curated text.
And then the third.
The third is the provenance archive, which silently holds onto all those raw sensory receipts from the very first layer. Just in case you ever need to audit why the AI believes a certain fact.
Which sets us up for the final piece of the puzzle, layer 5, getting the information back out when you need it, retrieval.
Right.
But in this architecture, retrieval isn't just, typing a keyword into a search bar. It's treated as active cognition.
Because human memory doesn't work like a simple keyword search.
No, it really doesn't.
Like, when you try to remember a colleague's name, you don't query a database. You think about where you met them, who else was in the room, or the project you worked on together.
You look for context clues.
Exactly. So this AI architecture uses multiple simultaneous retrieval strategies. It uses semantic similarity, yes, but it also uses something called recall by filter, which allows for exact metadata queries.
Like saying, show me everything from 2024.
Right. You can ask for every memory strictly tagged with a specific date or project.
Now, the paper also mentions something called queue-based bridging. How does that mimic human association?
Queue-based bridging is essentially associative memory for machines. If the AI pulls up one specific memory to answer your question, the system automatically pulls along related memories that share temporal proximity or entity connections.
Oh, so it just groups related ideas.
Yeah, it thinks, oh, well, if you're asking about the MySQL migration, you probably also need to know about the server downtime we discussed on that exact same day because they are connected in time and subject.
That's incredibly powerful. But, the white paper introduces a dynamic to this retrieval process called use-dependent reinforcement. And I have to admit, when I read the mechanics of this, I got a little anxious.
A lot of people do. It's the engineering equivalent of the testing effect in educational psychology.
Right.
The concept is that every single time the AI successfully retrieves a memory and actively uses it to solve a problem, the mathematical pathway to that specific memory gets stronger.
So the system organically learns that this piece of information is highly valuable to your daily life.
Exactly.
Right, and that sounds great for the stuff I use every day. But if the pathways for frequently used data get stronger, what happens to the data I don't use? Does the AI just start deleting my files?
Because the idea of my computer autonomously deciding to forget my data just because I haven't looked at it recently is terrifying.
It is a very rational fear, and the white paper tackles this forgetting question explicitly to ease exactly that anxiety.
Okay, good.
In cognitive architecture, forgetting does not mean deletion. It means decay.
And decay in this system is purely a matter of deprioritization in search rankings.
So the file isn't gone?
Not at all. Say you have an access to project brief in 3 years. Its neural pathway decays, meaning it just sinks to the bottom of the associative search rankings.
Out of sight, out of mind.
Right. It gets out of the way so it doesn't clutter your active workspace.
Yeah.
But the data itself is entirely intact.
Mm-hmm.
If you run a direct, explicit query for that old project name, you will instantly find it.
Oh, that's a huge relief.
Yeah, the white paper establishes a hard rule.
Right.
Explicit permanent deletion is only ever triggered by manual human override legal compliance requests,
Oh.
or correcting a catastrophic data error.
So your data is safe. The system is just organizing the desk so the old stuff is in the bottom drawer.
Exactly.
Okay, my anxiety is officially managed. So we have this elegant 5-layer biological theory. It solves the amnesia, handles the consolidation sleep cycles, and safely decays old information. It's brilliant on paper, but what really elevates this deep dive is Kelsi Guidry actually built it. Which brings us to the live alpha software release, BizerBrain.
BizerBrain is the version 1 reference implementation of this exact architecture. It's currently in public alpha, available on GitHub.
And the way it is physically constructed is just fascinating.
It really is. It ships as a single localized Docker container. Inside that self-contained environment, you get a web user interface, a local file system API to manage the data, and an agent skill that bridges the memory system to whatever AI language model you want to use.
You know, I was looking through the implementation paper, fully expecting to see some incredibly complex proprietary database technology powering this, but there isn't one.
Yep.
The canonical store, the absolute core of this highly advanced cognitive architecture, is quite literally just a folder of plain, unformatted markdown text files sitting on your local hard drive.
Yeah, the directory is literally just /srv/bizerbrain/brain.
It sounds almost aggressively primitive, doesn't it?
It really does.
It's like, if this is the cutting edge of AI memory, why rely on plain text files? Why strip out all the fancy high-speed vector databases that the entire industry has spent billions of dollars developing? Isn't plain text incredibly slow and outdated for machine intelligence?
It definitely seems counterintuitive at first glance, but using plain text markdown is perhaps the most genius architectural decision in the entire project.
Really?
Yeah, it creates what the author calls an agent portable boundary.
Oh.
The implementation paper uses a fantastic metaphor for this. It says the AI framework is merely a renter, but the brain, the knowledge base, is the house.
I love that. So the AI doesn't own the data.
Exactly. Think about how fast the AI industry moves. Tech companies release new, radically smarter AI models every few months.
Right.
If your memory architecture is locked inside a proprietary vector database controlled by one specific company, your data is trapped. You are completely locked into their ecosystem.
Oh, wow. Yeah.
But by keeping your knowledge base in plain, universally readable markdown files on your own hardware, your knowledge outlives the AI model.
You completely decouple the intelligence from the memory.
Precisely.
Yeah.
You could use an open source Hermes agent today, decide you want to switch to Anthropic's Claude tomorrow, and then move to a completely different framework next year. The AI models are completely interchangeable.
Because they're just renting the house.
Right. You just point to the new AI renter at your markdown folder. Because the folder is the absolute, undeniable source of truth, the knowledge is perfectly durable. Markdown files are just text. They will be readable 30 years from now, long after today's AI companies have changed or disappeared.
That puts an incredible amount of power back into the hands of you, the user.
It really does.
And understanding that the markdown files are the ultimate source of truth also explains one of the other really curious features of BizerBrain. It includes a human web UI.
Yeah.
At first glance, if we're building a brain for an AI agent, why on earth does it need a graphical interface for a human to look at?
Well, because fundamentally, AI agents are still going to make mistakes.
Mm-hmm.
They're going to misunderstand a conversation or capture a nuance incorrectly. The human interface is there so you can read the exact markdown files the agent is writing. You can fix typos, correct misunderstood facts, or just manually link ideas together.
That makes sense.
But it's also about privacy and human agency. But sometimes you need to write down private thoughts, strategic drafts, or sensitive notes that you don't necessarily want to speak out loud in a chat prompt to an AI.
Right, you don't want to feed everything through the chat window.
Oh, exactly. You can just type them directly into the markdown interface.
And because both you and the AI agent are looking at the exact same folder of plain text files, the synchronization is flawless.
Flawless. There is zero delay.
If the AI learns something in a chat and writes a note, that note instantly appears in your human interface. If you manually edit a bullet point, the AI instantly has the updated context the very next time it speaks.
Because there's no middleman database trying to sync two different systems.
It's completely seamless. The
Yeah.
human and the machine are literally reading from the exact same page.
Literally, yeah.
But I'm looking at the blog post that announced this alpha release, and the author is very explicit about managing expectations. They call it an alpha with rough edges.
Oh, absolutely.
So let's talk about the reality of the software right now. If you download this Docker container today, what is actually missing? Where does BizerBrain version 1 fall short of that grand 5-layer theory we just outlined?
Guidry is refreshingly honest about the current limitations. Right now, if you download BizerBrain, it is entirely missing layer 3.
Wait, the consolidation bridge?
Yeah. The asynchronous worker, the part that mimics human REM sleep off the critical path, hasn't been built into the alpha yet.
So the AI isn't going to sleep, sorting out my noisy transcripts and neatly superseding my old database notes with the new ones?
Not automatically in the background, no. Right now, the system relies on the AI agent itself to do that filtering upstream, right in the middle of the chat.
Oh, so it does it while you're waiting.
Right. The agent just decides in real time what's important and overwrites the text file directly. It's functional, but it's, much clunkier and it creates latency.
Are there any other missing pieces?
The alpha is also missing the deep vector indexing, so retrieval right now is leaning heavily on basic text search rather than that deep semantic queue-based bridging we talked about.
Which means there are probably limitations on how much data it can hold right now.
Yes, definitely. Because it's relying on basic file operations without the massive indexing engines, it's currently optimized for hundreds to maybe a few thousand notes for a single user.
So not for an entire corporation?
No, it is absolutely not ready for massive enterprise scale. The author describes BizerBrain v1 as the substrate.
The substrate.
Yeah, it's the bedrock. It proves that the plain text local folder architecture actually works. It's just waiting for the true cognitive layers, the background consolidation worker, and the complex retrieval indices to be built on top of it in future updates.
Okay, so the foundation of the house is poured, the walls are up, and now we are basically just waiting for the electricians to install the really advanced smart home systems.
That is a great way to visualize it.
If you've been tracking with us so far, you can see the massive paradigm shift happening here. We started by diagnosing the core amnesia of modern AI models. We looked at why the industry's current fix, just bolting a searchable database onto an AI and calling it RAG, is ultimately just a brittle Band-Aid that ignores how actual memory works.
Right, and to solve that, we explored a biological blueprint, a system that ingests data with strict provenance, uses a temporary workspace, relies on an asynchronous consolidation process to curate meaning, stores that meaning across multiple integrated layers, and then retrieves it dynamically through association.
And finally, we looked at how the BizerBrain Alpha takes that profound theory and grounds it in the absolute simplest, most durable technology possible, a folder of plain text files that outlives any single AI model.
It's amazing. The entire tech industry is being challenged to stop treating memory as a static database lookup and start treating memory as an active, continuous cognitive process.
Which inherently gives the ownership and control of knowledge back to the individual user rather than locking it inside the proprietary black box of a massive tech company.
It's incredibly empowering.
It really is. And that realization leaves me with a final lingering thought for you to ponder long after we wrap up here today.
What's that?
Well, if this cognitive architecture truly succeeds, if our personal AI knowledge bases become completely untethered from any specific company, model, or framework, existing on our own hardware as perfectly curated, infinitely durable digital brains, will those localized digital brains eventually become a more reliable, objective record of our own lives, decisions, and work than our own biological memories?
Wow. That's a profound question to end on. I mean, human memory decays biologically, it distorts under emotion, and it literally rewrites itself over time.
Exactly.
We're talking about building localized systems designed to never biologically degrade, to mathematically consolidate our exact thoughts, and to only forget when we explicitly command them to.
It really makes you wonder which brain you'll trust more in 20 years. Remember that brilliant, world-class assistant from the very beginning of our conversation? The one who woke up every single morning with total amnesia?
The unemployable one.
Yes, the unemployable one. Well, it looks like tomorrow morning they might finally remember your name. Thank you so much for joining us on this deep dive. We'll see you next time.